Myself, Dr. K.V. Shivanandmurthy, working as Assistant Professor in Government Engineering College, Ramnagara. In this video, we will see the assembly of plumber block. So I discussed in the earlier videos the assembly of plumber block. Here in this particular video, we will see how to create the power drawing components. Okay, body. So let us see the dimensions of the body as given. See, this is a symmetry. Okay, I'll create half of it and using the mirror command we'll get the full front view. Okay, so its base dimension is 168 and its thickness is 36. Go to drawing for creating the power drawings, solid part. Okay, protrusion command, select this particular plane, draw a line, connect this with this line. Okay, small dimensioning, this is 168. Okay, this is 168 and I'll create this particular shape. This is of thickness 14, the height is 55. This one. This one. Okay, select it. Okay, and we'll mirror this also. To mirror, select the things. Okay, now switch on the relationship handles. Now it's not connected here. If it is connected, it shows small rectangle symbol. Here it is not connected. Select connect the endpoint of this one and endpoint of this one. So now it's get connected. Switch off the relationship handles. Draw an arc. The endpoint of this one. So endpoint of this one. Now go to smart dimensioning. This is of what will set it as 38. Will do one thing, delete. Okay, now its thickness will fix. What is its thickness? We'll see the thickness of this one as 14 and this distance is 4. Distance between this one and this one, it's 14, and distance between this endpoint, it is 4, and now the distance between these two lines is 44 and distance between these two is 38. And now we can fix these two, distance between these two. 2 is, what is this one? It is 38. Okay, this is 38. This will be the 44. Take 44, and this side is 12, this is 3, and this is 38. Small dimension. This is 12. This will be 3. This is radius 19. And what else further? 44, 30 is over. The total height is 55. Distance between this one is 55. This is over 55. 14 is over. 4 is over. Radius 6 we'll do later. 12 is over. 3 is over. This is 19. Okay. Now this completes. And now thickness is 36. Return. We'll assign the thickness. Symmetric extent. It is 36. Enter. Finish. Okay. Now go for this one. In the bottom, see here, you can observe here bottom, there is slot of 2 mm slot, that is a rectangular slot, and this hole, there is a hole for a distance of through next, and there is a rectangular slot here. This rectangular slot, this dimension will be of square 20 by 20, and its height is 7 plus 2, 9, and two holes of diameter 10.5. Okay, I will select the base and will create sketch. Okay, select can go for sketch, select this particular plane, okay. First I will draw this one, this rectangular slot of depth 2 mm. Draw a rectangle. Okay, go to symmetric relation. This line is symmetric with this one, this line. Okay, now here you can observe here the distance between these two is 8, distance between these two is 8, and also the distance between here to here it is 8, distance between here to here it is 8. Distance between this line, it is 8. Distance between this one, it is 8. Distance between this one and this one, it is 8. Okay. Next, this rectangular slot is over. Next, there is a square slot of dimensions 20 by 20, and its center distance is, here they had given symmetry distance, this one 62. From here half of it is 62 divided by 2, here it is 31. Draw rectangle here. Okay, apply the symmetric relations, this one. Okay, Next, go to dimension. This is of 20. This is of 20. 20, and it's 20, and the distance between the midpoint of this one and this is, it is 62, half of it is 31. 31. Okay, now this is over, and then there will be two holes of diameter 10.5. This hole is at the midpoint of this rectangular slot, sorry, square slot, diameter 10.5. Enter. Small dimensioning 10.5. Next, I'll create this one. This is of dimension, this is 8 by 10, 8 by 10 rectangle, then two semicircles, and it is at a distance of, center distance 128. 128 divided by 2 is 64 from this reference line. Okay, take rectangle here, align symmetry with this one and this one, and next show the relations. Okay, next, small dimension, this one has 8, this one has 10. Okay, now the distance between the midpoint of this one and this one, it is 128 divided by 2, it is 64. So now trim these two lines, draw an arc, the end point of this one, point of this one, end point of this one, end point of this one. Okay, now nothing left. This is over, rectangular is over, this small square is 20 by 20 is over, two holes are over. Okay, next, return. Okay, the sketch is ready. Finish, go to cutout. Now select from the sketch that slot, accept, it is for a distance of 2 mm, enter this side, finish. See, this is for a distance of 2 mm. Next this hole is for through. Next, cutout, select this one, accept, this is for through, finish. Next, select this slot, this slot is for a distance of from here reference, this is 2 plus 7 9, accept, this is for a distance of 9, finish. Next, this circle is through all, select this small circle, accept, finish. Okay, now tools, edge board for this sketch. Now we can hide the sketch, it's not required. Let's see. Okay, now I'll mirror the cutout. Control I for diametric. Mirror. In mirror, you please go for smart mirroring. Select features. Cutout 4, cutout 3, cutout 2, cutout 1. Okay. Accept reference plane. Select this as the reference plane. Finish. Okay. Next. This is over. Then what is left? There is a cutout here, 43 radius. Okay. Select this boutique cutout. This is earlier we are in sketch. Go to coincidence plane. Select this plane. Fit. This is of radius 43. Okay, radius 43. This distance should be here to here. The distance we should fix now. This distance should be 43, 86. Okay. Return. Okay, select, right click on this one, edit profile. The distance between 86, these two, distance between these two, it is 86. Okay, return, it's updated. Finish. Okay, now we'll go for cutout. From coincident planes, select this one, fit. This is of radius 43. Draw a circle here of radius 43. Enter. And this is depth is for a distance of 55 minus 14. Return. And this you can select as side step. Select this one, you can go for a distance of 55 minus 14. Finish. Okay, anything left? That's it. There is a hole here. This hole, what is the distance from top? If I select the top plane, from top plane the distance of this hole is 12 plus 3, 15 plus 6, 21 plus this 19, total it's 40. Okay, 40 and its diameter is 6. Okay, go to hole option. Hole option, simple hole, its diameter is 6. And V bottom angle. Okay, select this particular plane, fit. Return. This is at a distance of 40. We can see this. Okay, in the bottom it is V shape is there. Finish. Control I for diametric. Select this view. Next is this is over, and okay, we have finished everything. There is a radius 6 here, radius 6. Okay, select the round. This is of 6. Enter. Finish. 6. Enter. Finish. Anything is left? Anything is left? Okay, nothing. Okay, now you save this as file. Save. It says now this component is body made of cast iron. Body. Okay, select create a folder. On the desktop we'll create one folder. It's plumber block. In that folder we'll save this as body. Let's save. Assign the material for this one. Go to tools, material table, assign its cast iron, apply to model. Okay, now this is cast iron. Okay, then save. Now file, new pot. Okay, now second one is this one, cap. This cap will be of this radius 19 and 36. We'll create this particular shape. Okay, go for this one. This is by again protrusion. Select this particular plane, draw two circle. One is of radius 19 and another will be radius 36. Okay, now here we will create this shape. Okay, I'll mirror this one. Now trim. Okay, now go to smart dimensioning. This is radius 19, radius 36. Distance from here to here it is 6. Distance, this is 12, this is 10. Go to small dimensioning. This is 10, 19, this is 36. Okay, this is 6, 12. Distance between this one and this one, it is 6. Distance between this is 12. Anything left? Then the distance between these two endpoint is 44. Anything left? This is 10 is over, 36 over 19, 12, 6 and 44. Okay, and its width is 36. Return. Symmetric extent 36. Finish. Now again, what is the total distance? We have not fixed this one. No, this is 43 86. This 43 86. This distance. Edit profile. Fit. Distance between these two. $86. Okay. Finish. Okay. Go to cutout. These two. There I will create two holes of diameter 10.5, and it is at a distance of 62. If we consider symmetry of it, 31. 10.5. Cut out. Select this particular plane of 10.5. Fit the distance between here to it is 31. Okay, mirror this one. Okay, later we'll do those things. Return. Finish. And there is one more work is there. This is its radius 12. Its radius is 12. Cut out. Select this particular plane and its center. Radius 12. Return. Selected hole. Delete. Return. Not go for a cutout. Select this particular plane. Draw a circle. Radius 2. Return. Finish. Okay. Go for mirror. Mirror. Select cutout 2 and cutout 1. Smooth mirroring. Accept. Reference plane. So finish. Anything left? No. There is an oil hole here. This is of hole diameter 6, depth 10. This counter bore of diameter 3. Okay. Let's go for hole option here. Hole on this one. Hole. Counter bore. Where I have to counter bore? Before that I should select one plane here. That plane. Create plane here. For that, go for parallel plane. This is the reference, and another plane will be tangent here on this plane. Whole option, counter bore of diameter 6, depth, sorry, it's in mm, it's 6 and its depth is 10, its dia is 6, depth is 10. This is, then this dia is 3. This dia is 3. Okay, this plane, return, finish. You can see the view. Okay, anything left? This is over. Okay, we have completed the cap part 2 and we'll save. This is made of again cast iron and there is an arc here. See, the final arc is 43. There's an arc is here. Go for cutout, select this particular plane, fit, arc of radius 43, return. You can select this one, side step, finish. Okay, now we'll save this as cap. Okay, and it's of cast iron. Cap, save. It is made of tools, material table, assign the material. It's of again cast iron. Apply to model. See, body and cap both are of cast iron. Now for identification purpose I'll change the color of this one. Tools, part painter, format part painter, select this one as color. I can give it as tan. Apply. Okay, close. Now we'll save again. Okay, third one is bearing bottom off and fourth one is bearing top off. Now first I'll create the fourth component, bearing top off. From that there is a slight change, we'll create the component 3. Okay, first I'll create bearing top off. File, new part. Okay, for bearing top off, using revolve protrusion, select this particular plane. Should create this distance is 50, 36, 22, 4, 22. Okay, draw a line. This one, midpoint is connected to this one. Small dimensioning, this is of 50. Next, draw the approximate shape here. This one. End point. Okay, now this should be equals to this one, this should be equal to this one, this should be equal to this one, to this one, equal to this one, and relate the relations and the dimensions. The distance between those two, 36 and 22. 36 22, and here the distance between these two, okay, it's there 25, 35, 38 and 50. 25, 35, 38 and 50. Okay, this is symmetric diameter, so go for symmetric dia. From here to here it is 25, next 35, 38, 50, 35, this one to this one, 35, next this one to this one, 38, 38, and finally this one to this one, it is 50. Okay, and now select the axis as this one, return, it's 180 degree, finish. Now the bearing top off is ready, and there is a hole of diameter 4. There is a hole of diameter 4 cut out. Select this particular plane, diameter, return, finish. Okay, now we'll assign the material for this one. This is bearing top of brass. Save, bearing, bearing top of okay, bearing top of, save, and we'll assign the material, tools, material table, its brass, apply to model, its color changes. Okay, save. Next, again there is no much difference, bearing top and bearing bottom of. The only thing is here in bearing top of oil hole is there, here it is protrusion of 5 mm. Okay, I'll save the same component as, save as bearing bottom of, save. Here in cutout we'll delete this one. Okay, instead of this one, tools, edge bar, right click on this one, go to edit definition. In edit definition there is an option called extend step. I want to extend this by 180 degree. Enter its direction, downward direction. Finish, because bearing bottom of it in this particular shape, that's why. Next there is an oil hole of, see there is a protrusion of 5 mm. What is this distance from reference line? I have to check this one. From this reference plane, what is the distance I want to calculate? So it is at a distance of, this is not on 25 mm line, this is 25, next is 35, half of 35 means 17.5 plus 5, 22.5. this is at a distance of 22.5. create a reference plane at 22.5, parallel plane reference to this one at 22.5, enter. Okay, go to protrusion, select this plane, draw a circle of protrusion dia 6 mm, 6 mm dia, enter, return. This is for through, next in this direction, finish. See, okay, Control I. Now we'll save this as, we already saved this one. Assign the material, tools, material table, it's already assigned for browse for this one also. Okay, next component is body is over, cap is over, bearing top of, bearing bottom of is over. Now we'll come for this one, bolt, M10 bolt. In M10 bolt the base dimensions will be of 18 by 18 square for a thickness of 6.5. File, new, part. Okay, select this plane, connect this one to this one, this one to this one. Small dimension of 18, it's of 18, it is for a thickness of 6.5. return, can give it as symmetric extent 6.5. is it 6.5? yes, 6.5. finish. Next, this cylinder of M10 10 diameter for 75. protrusion, select this particular plane, circle of dia 10, this is for a height of 75. Okay, protrusion, select this one, 10 dia, return, this is for a height of 75. finish. Okay, and also there is a thread, external thread for a distance of 26 mm. go for threading, select the cylinder, select from this particular end, there is a finite day value for a distance of 26. Okay, next say there is a chamfer of 1 mm. How will you take the chamfer? Means this diameter is 10.1d means 1 mm. Chamfer, select this end and set bank angle as 1. Okay. Finish. And here there is a round. Okay, for that go to revolved this one, revolved cutout, select this opposite plane, working with zoom, draw a line with an angle of 30. Okay, now this is, if you want can show both angle between this one and this 30. Select the axis, this one, return. It is asking either this side or this side. Select this side and for 360 degree. Finish. Okay, this completes, and I'll save this as M10 bolt. Save as bolt M10. Okay, I'll save this as bolt M10. Save, and its material will assign FE410. Tools, assign the material FE410. Apply to model, differentiate by color. We'll assign some color for this one. Hot painter, we'll assign this color for this one, gold color. Okay, close and save this one. And next is, this is nut of this is nut, square nut. This is square nut. Okay, we'll go for, this is internal dimension 10. Okay, square turn of thickness 8. Go for, that is for a file, new part. Okay, for protrusion, select this particular plane, draw a circle of dia 20, dia 20. Sorry, delete. Dia 20, enter 20. Okay, now draw an hexagon, take line, intersection point, this point, this point, this point, and this end point. It's not connected. This intersection point and point. Okay, now we delete these lines. Delete, 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 Okay, now it's not connected. Connect this endpoint with this one, and there is a wall of dia 10, and it's written its thickness, symmetric extent, its thickness is 8 mm. Finish. You can observe here its thickness is 8. Avoid sharp corners. Go for revolved cutout. Select this particular plane. Take a line of angle 30. Angle between this endpoint and this one is 30. Axis is this one. Return. This is for 360 degree. Finish. Mirror. Select this cutout. So accept. Reference plane. Finish. Okay. Now we'll save this as nut M10. Okay, nut M10. So we'll save. Assign the material tool, material table. Select this as FE410. Apply to model. Change the color of this one. Format, part painter. Select it as red. Okay, save. Next same thing, lock nut. There is no difference between these two, only the thickness. Okay, I'll save this as file, save as. Nut M10 lock nut. Lock nut. Okay, save. For this protrusion, right click, edit definition. Here the thickness instead of 8 will give it as 5. Finish. Fit. Say undo. Fit. Right click, edit definition. For 5. Finish. Fit. Okay, we'll assign thickness as tools, material already assigned maybe. Okay, change the color, format, part painter. This is of orange or else green. Next one, and fit. If you want, you can do this one also. Remove cutout, select this particular plane, take a line, angle 30, there. Select the axis, return, this side 360 degree, finish, mirror, tools, edge bar, select this command, cutout, smooth cutout, accept, this plane, finish and save. And last one is shaft, file, last one is a shaft of diameter. This is 25 mm diameter, length is not defined, so length depends on this one. This bearing is for a dimension of 50 diamonds, 100. Will file, new, part, okay, protrusion, select this particular plane, circle of 25 dia, return. This is for a distance of symmetric extent 100, and we will say this as shaft, 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 okay, SHAFT, shaft, save, and assign the material. This is also FE 410, and we'll change the color, this one. Format, part painter, select this as select this color, this is as violet, go to this one, close, let's say this one. Okay, now we have created all the components, okay. Now we'll go for start doing the assembly. Okay, for that one, assembly, go to assembly. Okay, my file is in this one on the desktop, it's Plummer block. Okay, first is body component, drag the body component here, next is bearing bottom off, and okay, we'll finish all the assembly by using flash fit command, flash fit, this one, this hole, right click, select this one, and also flash fit the axis with this one, it's aligned and its color changes, fit, right. Next, bearing top off, here we are in flash fit only, this edge, this one, next cap, here click this face, this one, and also this hole at the axial line of this one. Next is bolt. For bolt we'll use insert command. Insert. This face is in mate with this one, and also this cylinder, this one, diametric. Next, a nut, flash fit, this is in align with this one. Next, lock nut, this is in align with this one. Okay, fit. Next, shaft, this is in align with this one. Move for some distance. Okay, fit. Control I, diametric. Okay, now I'll mirror these components. Okay, go for mirror, select the components. This is for mirroring. I select the reference plane. Now this lock nut, and bolt, accept, okay, and finish. Now this completes assembly also. Now save the file, save as the plumber block assembly, save. Now we'll draw the drawings. Okay, sectional, front view, top view, and isometric view. File, create drawing. Okay, or else cancel. We will close this one. No, we'll check the views. Control F front view, Control T top view, Control R right view, Control L left view, Control B bottom view, Control I isometric view. Okay, file, create drawing. Okay, now next, front, customize. This is my front view, front, top view, left view, and isometric view. Finish. See, now this is A2 size sheet, but you students are supposed to give printout in A4, so we'll change this sheet setup, background A4, switch off the background, and our default size A4. Okay, now select these things and change the scale factor. It is 0.5. Enter. Okay, now see, this is an independent view. Isometric view not depends on this one, but these are interrelated. If I know any of the if I view, other views will also disturb. Okay, so there is this view, this is top view, this is front view, this is left view. Fit. Okay, but I'll represent off sectional front view and top view. This left view is not required. Delete this one. Yes. Okay, 0.6, 0.6, previously 0.7, enter, 0.7, enter. Okay, now we'll move this one. This is front view, this is top view, this is isometric view. We'll give this as 0.7. I'll place isometric view here. Okay, now this is the front view, but I want to draw this off sectional front view. Okay, I'll delete this front view. Yes, now from this one I'll generate the off sectional front view. Select cutting plane, select this one, work with zooming this area. Finish. Either select this one or this one. This one. So, okay. Sorry. Delete this one. Cutting plane. This one. Finish. Fit. Now section view, select this one and place this one. This is off sectional front view, but in this section also it is showing even bolt, nut and all section. We will change this one. Go to properties, right click, properties, general section display, off sectional front view, display ನಲ್ಲಿ here what are the sections not to be shown in hatching. Select this one, shaft, nut, lock nut, bolt, switch off the section. Okay, and update the port. Okay, now this is off sectional front view and this will be the top view. Here show top view, enter, click here. I want split a little bit here. Okay, this is off section of front view, this is top view, this is isometric view. Select this one, update. Now lastly I'll show the part list. Go to part list, select this one, finish. Okay, in this one document number is not required, we can delete this one. Properties, columns, this document number just remove. Okay, now here you can see okay, this is title, body made of cast iron, body variant of like this one. Okay, this is part list. In examination you are supposed to give this sheet print out on A4 side, the off sectional front view, top view, isometric view. If you want students you can insert your name. See, for this one you can type it as text with font size 6, isometric view, and students you can type your USN here, 1GG18ME043. okay, this completes Plummer block assembly and also the views. Okay, thank you.